Hello दोस्तों, welcome to Code the Unseen. In today's video, we are diving deep into everything you need to crush your next SQL interview, whether it's at Google, Microsoft, EXL, or any top company out there. These are the 20 questions we will be solving today. If you already know the answers, feel free to skip ahead, but if not, stick around. We'll start with solving practical questions and then we'll jump on to theoretical concepts you need to master. Don't forget, all the notes are linked in the description below. Let's get started. In the first question, interviewer have asked to fetch all the movies starting with M, but the catch is you can't use like function. Instead of using like function, which is a typical approach, we will use left. Left function extracts the first character of the title and check if it equals to M or not. A simple and efficient alternative, I'll say. So here, if you see, this is the query, and you will get all the movies starting with M, right? In the titles column, you can see that clearly. Now let's jump on to the second question. This question, interviewer have asked us to calculate maximum working hour of an employee. So let's see the information available in the employee table. Okay. So we have employee ID, name, clock in, clock out time, salary, and salary date. These are the six columns which we have right now. To calculate the salary difference, what we can, the time difference, what we can simply do is we can use query wherein we'll first calculate the time difference, then sum these hours for each employee, and finally we'll sort the result in descending order using limit to 1. And that's how we'll get the employee with maximum number of working hour. I hope this gives you some sort of clarity around how you can fetch or solve this kind of problem statements. Now, coming down to the third question, wherein we have to calculate the salary difference from previous row. But the catch here is that we have in the table, which is again the employees table, should have at least two salary records. So the query for this will be this. First, we filter employee who have more than one salary record in the subquery within, or you can consider it as a first table from or a subquery from which we are joining the test.employee table. Then we use lag window function to get the previous row salary for each employee, partitioned by ID and order by salary date. Now we calculate the difference between salary and the lag salary. And here you receive the salary difference. So we have already solved the three questions. Now we only have two questions left. In the fourth question, interviewer have asked about the third highest salary in the employee table, which is quite simple. We can solve this using offset, and the query for this will be Jane Smith have received the third highest salary in the employee table. Sorting salary in descending order lets us view the highest ones first. Using limit, we have limited it to the first one, and offset, we skip the first two rows and fetch only the third row, giving us the third highest salary directly. This is the exact thing which has been working here. Now comes the fifth question, wherein we have to compute the cumulative sum or average of monthly sales data. So for this, we can simply use sum over function. I know these questions sounds pretty much trickier, but this query for these are very simple. Wherein what you can do is you can simply use month sales
from the sales data, and you can simply perform sum sales over and then order it based on month, because we need a cumulatives, and that's why we are ignoring the partitioning part here. So the sum function with over clause calculates the running total by adding sales month by month. And we can simply see here, right? 1,20,000 plus 1,50,000 is 2,70,000. And then adding 1,80,000 to 2,70,000, which will lead us to 4,50,000. And that's what is happening for all 12 months. Even if you have to calculate average or running average, you can simply replace sum with average and you'll get the output. What it's doing is it's adding up 1,20,000 plus 1,50,000, which is 2,70,000 upon 2, which is 1,35,000. And that's how entire things are working on. So this was all about the practical questions. Now let's jump on to the theoretical concepts.
We'll cover two major concepts in this video and we'll add the solution for remaining theoretical questions in the description below. So let's get started with difference between DBMS and RDBMS, which was the 13th question. What exactly a database management system means and how it's different from relational database management system. So storing any information in a specific type of format, maybe XML file or a JSON, is a part of database management system, whereas storing data in terms of table with relational entities or concepts constraints like primary key, foreign key, etc., is a part of relational database management system. So this was about database management system and RDBMS, which is relational database management system. Now we'll jump onto the concept of normalization. So now the question arises, what is database normalization and what are different normal forms? Normalization is like organizing your messy wardrobe. It helps reduce unnecessary duplicates and make sure everything is in its right place so you can easily find what you need. There are four major type of normal forms. First normal form, second normal form, third normal form, and then Boyce-Codd normal form. The rule for first normal form is each column contains atomic values. No list or set values are allowed. There shouldn't be any duplicate rows. In this case, within student courses table, it's already in first normal form. Since there are no multi-valued columns which contain lists or sets or any, you can say, list aggregated values, all the columns and rows are unique. There isn't any duplicate values as well. Now let's jump on to second normal form. The rule for second normal form starts with the first normal form, which means the table must ensure atomic values. Then comes removal of partial dependencies, meaning every non-key column should depend on full primary key, which here could be student ID plus course ID, because both are needed to identify a record. The only issue here is instructor office. Because it's not dependent on student ID plus course ID, it's dependent on instructor. To solve that problem, what we need to do is simply break the table into three different segments of student courses, courses, and instructor, wherein instructor office is now dependent on instructor, and remaining two student courses and courses are still dependent on their individual primary key. Now let's jump on to the third normal form. The rule for third normal form is first, it's in second normal form, which means the table shouldn't have any partial dependencies. Second, there are no transitive dependencies, meaning non-key column must depend only on primary key, not on other non-key column. So let's see this table. There are three different problems here. Student ID is the primary key. Course name depends on course ID, not directly on student ID. The second problem. And the third one is the instructor office depends on instructor, not on student ID again. So To solve this problem, what we need to do is simply split the table into four different tables: student name, student courses, and instructors. Now, what happened now? No update anomalies are required. Like change in student name 1 is updated everywhere. Second, data integrity. Every piece of data depends directly on its table primary key. No hidden dependencies. Efficiency is the third metric which you can consider. Smaller focus table means fewer duplicate entry. It generally ends up saving storage costs. Now let's jump onto the fourth normal form, which is voice chord normal form. The rule for voice chord normal form is it's in third normal form, and the second rule is every determinant is a key. A determinant is any column that can uniquely identify another column. Let's tweak the previous example, which you can see in the table. The course ID is the primary key, but instructor can also determine instructor office. So, to solve this problem, what we can do is we can simply again split the table, and now instructor is a determinant but not a key, which is a violation of voice chord normal form, right? And for that, we have simply break the table into courses and instructor, wherein each determinant have their own primary key, or you can say each determinant is a key now. So these were four different type of normal forms, and as I told you in the beginning, all the remaining theoretical questions are in the description with solution. If you find any of the solution little bit complexer, or you need a separate dedicated video on that, please feel free to drop a comment regarding that section. I'll for sure get back to you with a new separate video around that. Thank you for watching. I hope this helps you crack your next interview. Keep coding the unseen. Thank you.